Happy New Year, everyone. It's still the pre-show. I'll do it again later. Good evening. How are you all doing? Oh, I was wondering about that. I didn't remember which lens I put on the camera. I bought a new one when I was in Shenzhen in November. And this is the new one. You can see it's very wide. Now you can see even more. Even more of me. Hope Santa. Oh, let's turn down the music a bit. There. Oh, let's turn off my phone a bit. There. Nice. So I'm not sure about this lens. It makes the room look even bigger while it's not big. It's like this is like the edge of the room and this is the other edge of the room. So I don't know. I mean, this lens makes it works. I don't know. Maybe in a future setup, if I have to sit closer, this would be a good lens. But for right now, this feels a bit too much. You're watching this on Starlink during a snow blizzard. I don't think Starlink would survive a snow blizzard greatly. Does it cut out, Mr. Korsmit? Are you in the Netherlands? Korsmit. Could be. Oh, I didn't prepare a power supply cable. Well, we'll fix that later. We had a lot of snow this week. It's melting now, but I wonder if there's going to be new snow during the weekend. We'll see. I'm debating switching back to the new lens. Alright, wait. No, to the old lens. Yeah, I think I'm going to switch to the old lens. So, let's go here. Then you can at least see my hands. Right? The snow doesn't stick. Nice. Northern part of NL. Okay, well, I'm in the southern part. I'm near Den Bosch, so in North Brabant. And here it's not snowing, and it's actually still melting. So, interesting. Yeah, okay. So let's change this camera. Oh, wait, it's stuck. Okay. Yeah. Oh no. Okay. Hello. Wow, it's like my face is here and the camera's there. It's really close. It can focus up pretty close. Interesting. Okay. Can I change the lens while it's on? If I can get enough cable. Hold on, I need to finagle the wires here. Okay, I got that one. Can I get this one? Yes. Okay. Let's take off the lens, see what happens. Oh. Okay, didn't like that. Hold on. I think it's this cap. Yes. Okay, good. Okay, and let's put on this one. Hello? Yeah. Oh, you can see the top cam. Okay. Good. So the lens I took off was an okay, you can't see that. Okay, we can see here. Was an 18. So that's really wide, and now we've gone back to a 24. So let's get all the cabling situated again. Okay. Almost. I need to apply my spacers. Okay. Let's go back to the face view. Yes. Okay. This is the view we're used to. You can see all the neat storage boxes. Yeah, that's true. That's true. That's true. You preferred the other one? Really? Okay. Well, I'll think about it. Hey, Happy New Year, Greg and Malky? Malaki? I don't know. Was it Malaki before? I don't know. From the Cressy family. Looking forward to more live streams and product. No worries about that. I have some big plans for 2026. Like all the plans that didn't finish in 2025, I want to do in 2026. Do a poll. Let's go for the other lens. Why, you just want to see more of the office and less of me? Is that it? That's it, right? Aw. Now I feel, no, I don't feel anything. Gelukkig nieuwjaar. Okay, new poll. Poll. Start a poll. Which lens? Wide one? Standard, less wide one we always used. Oh, it's too long. Start poll. We have 3 minutes until the show starts. It's got more depth perception. I need to turn the ISO down one tick. There. Why is everyone screwing with me? Okay. We'll see. We'll see what the poll says. Where does this go? This goes over here, I guess. I don't know. But then you can, like, this shot has been carefully curated so that everything that you shouldn't see or is a mess is out of shot. So if I change it to the other lens, you know, that's the problem. How much should I pay for the lens? So here in the Netherlands, they're about 800 euros, and I think I paid like 500 something bucks. So that's a decent discount. Can you do a staircase mod video on how to do it, or even just the programming, as there are so many conflicting videos out there with PIR sensors? I've never done one myself, so that's a bit hard, but I might look into it. We don't care. We are just looking for the LEDs. Oh, now is a good time for an ad. Close. Just finished setting up a remote Zigbee network to bring faraway devices into local Home Assistant. Oh, alright. Was a pita. Networking is hard. Okay. Well, I just generally do IP networking, and that's okay. Oh, someone finally noticed. Foxionaire said, "Awesome hoodie. Will you sell merch, or is that in the planning?" So I've always said I won't do merch unless I have 100,000 subscribers on YouTube. So this was just no, it's over here. A fun thing. I was like on AliExpress during the 11th of the 11th, and they had like $10 printed vest, and I was like, hey, $10? We can give it a try. And so this is the vest. But if you pay close attention, there's already, I don't know where it is. Is it? Yeah, there's already a hole. There's already a hole in the vest. So this is like premium ultra deluxe quality. I haven't even worn it once, and there's already a hole in it from washing it. And on the back, there's also a backside. Oh, look at that! It's my logo! But yeah, this is like the most ultra crap cheap quality they could possibly find, and then they made it cheaper. I don't know how. But it survived washing it once. I mean, it's not bad. You haven't aged a day. Oh, thank you. Sometimes I feel like I've aged some days, but oh, my monitor just died. That's interesting. Oh, it's coming back. Okay, monitor's back. Okay. Cool. Could you do a room tour? Well, the room tour is very short because this room is not very big. Okay, anyway, we're ending the poll. We're now officially into the stream. And it seems I have to switch back to the wide one. Damn it. Yeah, I knew this would happen. You guys knew it would happen too. Okay, well, here's the lens cap. Hold on. Here we go. Okay, let's put on the lens cap first. There. I'll go to the other view. Okay. Can I reach it? Somewhat. Maybe if I... There, you can now see the camera. Okay. So let's take this lens off. Oh, it's not white. It actually does... Something does still happen. Interesting. Okay. Okay. There. Focus. Yes. Okay, good. This one, okay, has a cap. Of the panels? Which panels, Rich? The ones we worked on before? Where we did the 4-panel variant of? Oh, this needs to go. Okay. Okay, now I need to align it. Hold on. So, it's so wide, it sees things that are right beside it. So I need to move it here and then angle it, I think. Yeah, it's not straight, I think, but we're getting there. And let's up the ISO. No, we'll leave it the ISO. Okay. Okay, we're back to wide view Quindor. 4x5 version, damn. Make sure to share your progress on the Discord, because I want to make one with a Dig Octa also, like for on the back wall over here. Maybe 4x4 panels, 3x4, I don't know yet. Because that could be really cool. And I'm just giving you a hint or a tip. Try and have a data wire per 2 panels. First, because you stay under 600 LEDs, you have 512 LEDs. I know you don't have those data channels right now because the Dig Octa maxes out at 8 channels, and then you know the WLED can't really drive above 200 LEDs or 2000 LEDs that well. You might try Moonlight; it might do better than that. But maybe in this year we might get a controller that can do a lot more. Who said that? I don't know. So yeah, why did YouTube enforce that stupid handle thing? Possible to tell who's who all of a sudden. Huh? Oh, okay. Ready to beta test for you. Yeah, exactly. So make sure you're on the Discord and add me or ping me, and we'll get that figured out. No, well, no, this board is not developed yet. I will show some secrets today, but it is absolutely in the planning. So I've already done a lot of the groundwork, basically on the Dig actuator board. That was a test platform for that. So yeah, who knows? I keep watching myself. Okay, so today we're going to do power supplies. I thought we'd take a look at some of them first. And let's see. Oh, Philip isn't here. Let's see. Do we have some people here? We have 63 people. Okay, that's good. Right, so let's zoom in a little bit. And not too much, because for some of these power supplies, we're going to need to be zoomed out. Because one of them is totally bonkers. But look how big I am. Okay, first off, we'll leave these packaged until we unpackage them. I'll unpackage one of them. These should all be listed in the video description. These are some Did I hear my name? Oh, okay. Philip is here. Okay. You generally like the power supply testing, so. This is a 250 watt 24 volt power supply. And this is the same one. Oh, I haven't. We're drinking zero iced tea green stuff. I haven't opened it yet. But we also have a 12 volt one of the same variety. So a lot of people like using these enclosed power supplies instead of framed or shelled. Oh. That didn't arrive okay. That's not supposed to be like that. It's okay, we can fix that. There, fixed. A lot of people don't like open frame shell type power supplies. And is the other one bent also? Oh, the other one, what? It's bent up. Jesus. What happened? Okay. The cable does not seem to be damaged. No. Seems it's also double insulated because you have the insulation on the wires and the outer sleeve, so that's good. Anyway, people don't like frame type power supplies and they like these waterproof versions. So I thought, okay, let's get a 12 volt and a 24 volt 250 watt because that price performance wise seemed best for that category. Okay. Could have opened that differently maybe. And they also have the guy she tells you not to worry about. So these are 600 watt variants. And now, like before, a lot of those power supplies I bought were bought with the intention of proving or showing that those are bad. These I bought in the hope that they'd be good. Bent? Oh no, is there more bent? These aren't... Oh, wow. Okay. It's like folded over. Is it that easy to do? I mean... No, it's not easy to do. What the hell? What hit it? I mean, it's just a mount. It's not gonna influence anything, but yeah. This is the only one that arrived unscathed. Okay. I guess so. Well, we'll see if they still work, huh? Yeah, but so potted waterproof power supply that come pre-cabled. That's going to be interesting. And so the 600 watts have two outputs, and the 250 watts only have one, and that's probably the price jump if they have to change between these chassis, because like the 200 watt and the 250 watt was like 80 cents difference, but then the 250 watt and 300 watt was like $8 difference or something like that. So it's like, okay, 250, that's this tier, and then 600, that's this tier. So this will do 25 amps at 24 volt or 50 amps at 12 volt. And this will do 10 amps at 24 volt or 20 amps at 12 volt. Okay, so that's one of the categories I want to test. And we'll see if we test all of the same type or not, because I have a lot more. And there's a few in there that I'm like, what is going on? Like this one, I think this is one of the interesting ones. Yes. This is from an audio brand. I don't know if any one of you will know it, but this is from Aima, and it's a big brick. It's like, and it's a 48 volt 10 amp power supply. So 480 watts in this brick. And the reason it's this well, fairly small size, it's not small, but it's also not giant, is because it's supposedly GaN based. So it doesn't use silicone switching chips, but gallium nitride switching chips. Whoa. Okay, but it's a nice enclosed brick. There's no fan. And yeah, 480 watts could be interesting for diff power, right? Yeah, we're going to test that. And then there's two more here that are slightly less interesting. So we're not going to look at that. But I want to show you one more. And that's this guy. This is definitely the power supply she tells you not to worry about. Because I saw this and I was like, that can't be real. What kind of nonsense is that? It's a chonker. A chonker of a brick here. This thing is humongous. I mean, it's bigger than my face. Look at my drink bottle here. Look. Okay. But it's a 12 volt, 20 amp power supply. What? Well, I guess it's still smaller than this one. I mean, this one is also 12 volt, 20 amp. But I mean, look at it. This one that can like cool with the metal and stuff. It's huge. Do I have a dig quad here or something like that? Not on the disc right now. Here's an LED strip. Oh wait. Here we go. This is a Dig Octa brainboard. A Dig quad is about the same size, or an we can just add. We can add an AN Penta Mini, like a few. We can add a few AN Penta Minis. Yeah, barrel jack, 20 amps. But this cable, I mean, it doesn't even bend. So, I mean, I don't know. We're going to snip this off because we're not going to use that barrel jack. So, I got it today. Or no, well, I got it recently, but I unboxed it today. And it said something interesting. It has a Cisco part number on there. Can someone look up this part number? 341022203 Rev A0. I mean, it has all the stuff. Revision S5. Oh, it has a serial number even. So maybe this is a repurposed Cisco power supply. This label looks official. And there's like a seal on here. 2025. 9. Okay, well I bought it in 10 or 11 I think. So, okay. Yeah, it has a 3-prong. So this thing is a chonker. It's like the biggest power supply I've ever seen. Well, in this type. Okay. So 12 volt 20 amps is 240 watts. And, well, I guess then, you know, this is also 240 watts. They're both... no, wait. Yeah, that's 240 watts, this one. But 12 volt. But this one is 480 watts. What? It's smaller and it's double the wattage. Now it's 48 volts, so, you know. Is there a fuse? I don't know. These are actually for sale from a few sellers on AliExpress. I linked the one I bought it from. But if you need a lot of 12 volt, like, I was going to show this later in the stream, like for a Dig Next 2, which has a chonker input and is rated for, well, it's rated for max power recommended 15 amps, but it can do about 20 amps fully loaded, because there's 2 5-amp fuses and one 10-amp fuse. This would be the perfect pair. Now, of course, I don't have a barrel jack, because I don't believe this will survive unmelted. But we'll just snip that off. That's fine. But yeah, if you need like 20 amps of 12 volt with a dig next to, perfect. Anyway, yeah, a 4-prong actually makes more sense than a barrel jack. Can we try and melt the barrel? I don't have anything that will... Do I? I might have. One moment. I need to dig in my boxes. Let's see if we can melt the barrel. Hold on, hold on. Over here. Yeah, these... Oh, don't click stuff. These might stand the best chance. Right, because they're decent wire size. Let's see if they fit. Oh, it fits. Okay, let's leave some of those on the disc. I mean, this sweater, I'm sweating. I'm gonna take it off. Sorry. You can look at the logo a bit more. Wow, it's really, what a crap stuff that is. Okay. The print is fun, but it's like really, no. The quality is utter shit. YouTube doesn't notify me about your stream. Bad YouTube. Oh no, my mouse power changed. Okay. Anyway, we'll use we will try the barrel jack melting today. So what do we want to start? Oh, I'm stuck. Okay, what do we want to start with? Do we want to start with chonker? I guess it's going to be the most exciting. Yeah, I don't know. Indeed, there's no logo. It feels official. I don't know. You never know with these things, right? Let's start with the chonker and see if we can melt some. Oh, this is that's pretty common. There's actually two there. Those are common mode chokes. So if they have issues passing regulations, they can put a common mode. Wow, this even the Velcro's like industrial grade. They can put a common mode choke on there, which will dampen some of the emissions, common mode noise, basically. So yeah, those are common mode chokes. For some reason, it has two. I don't know why that would be. I guess maybe two is cheaper than one big one. I don't know. Okay. Oh wait, I wanted to measure. Oh. Is that normal? I guess so. I want to measure the continuity of this power cord. Let's see. It says alive, okay. Yes, good. Okay, let's go to continuity mode. Okay. Can we beep it? Yes, good. Does it show up on screen? Yes, okay. Let's test this power cord. No. No. Wait, what? Okay, let's test it over here. Yeah, okay, that's good. Okay. Yeah, let's test this part again. Yeah, okay, okay. Okay, power cord's good. We have earth and everything. Okay, let's make sure that's in there because it needs to deliver mucho amps. Okay. And how do we now hook... I need to organize my desk here. Hold on. And then we'll spend like 5 minutes starting up my tools. Come on, come on. Okay. Okay. I need the 16 gauge testing wire, I think. Yeah. Okay. So we use the plugs we made like a stream ago. And this is 16 gauge. So I should be able to use a Wago. There. Well, it needs to do 20 amps. Yeah, poor Wago. Okay, we'll need to strip this. Make sure that works. And so... Wow, my desk is a giant pile of... I don't know what. Okay. Attaching the leads. I mean, even that 16 gauge will get warm from the 20 amps, so I don't know how this is going to work. Okay. That is in the tester. Let's turn on the tester. Okay. Let's strip this. That's not a lot of copper, man. Hold on, I'll show you. I messed it up. Okay. And, okay. How are we supposed to pass 20 amps through this amount of copper? I mean, what? What's going on? Even this 16 gauge, of course it has a wire ferrule, but it has way more copper than whatever this is. Does it say on there? Oh, wait, no. Ah, wait. This is, of course, from my barrel jack. Oh. Well, we'll see. If it melts, we just take it off and test the bare wire. Okay, let's fold this double, just to give it the best chance. Okay. Yeah, this barrel jack will not survive. Let's do a poll. When does the barrel jack melt? Let's see. Poll. When will barrel jack melt? 3 amps? 5 amps? Okay, I need more options. Okay. Let's say, okay, 10 amps, 15 amps. There. And it's not a long wire. It's not a long wire. Look. That's how it comes. I don't know, man. This is going to be bad. Where's my... I need 2 safety glasses. Okay. We have some safety glasses. Let's get the tester online. I've been playing with this, so I'm hoping I can make that work. The software is not coming up. Why not? Oh, it's showing somewhere. Oh, there it is. Okay, I need to move it here. Oh, no, no, go away. Okay. And then I need to resize it. Oh, now there's two. Okay. I firmware updated it. Let's go to CC mode. Yes. Okay, I think this works. So now we can see what the tester is doing. And now we need the next tool. That's the thermal camera. Okay, let's go to Wi-Fi. General. Let's see how many tries it takes this time. Why does it sound that? Why does it? Oh, okay. Yeah, okay, we're on Wi-Fi. That just sounds horrible. Okay, thermo tools. Oh, this is a Guide IR E4. Oh, they have optimizations. Okay, download and install. That's what you should do during a live stream, right? Update your software. There, we're downloading new Chinese software. I now have one button that only says restart now. I don't know if they mean the PC or the software. So if the stream is suddenly gone, I am clicking it now. Uh-oh. Okay, it seems my stream is still running. Okay, let's update this stuff. Close. Okay. Does it now start the software for me? No, of course not. That would be too easy. Okay. The Guide IRs are pretty decent, but I got them mostly because of the streaming feature and the macro lens. So this one also... Wait, I can't see my OBS. Hold on. This one also has a macro lens on top of it. Then it's pretty good for PCB inspection, but this is an expensive one because it has a much higher resolution, much higher frame rate, and has the Wi-Fi streaming when it works and stuff like that. If you just want to do real-time analysis, I think you could do with a bit lower tier, maybe the E2 Plus or the E2 with a macro lens. That should be decent. Right, let's go to video, connect LAN. No, that is not the IP address. Okay, I need to look up the IP address. 103. Okay. Wait, which wireless network is it on? Oh, it's on private. Okay. Hold on. Need to look up at DHCP stuff. Okay. 28. Yes. Let's see. Let's see. Can we connect? No, 300 is certainly doable. Yeah, okay, I have to click this join button or connect button like 500 times, so bear with me. The stupid thing is this camera will not tell you the IP address it has on the wireless network, which is like totally stupid. Let me double check the IP. Yeah, that should be it. Failed to connect. Okay, then I often have to, you know, play around with it a little bit. So like, okay, turn on RTSP. Doesn't need it, but you know, can never hurt, I guess. Okay, it doesn't work. Confirm. Oh, it suddenly worked. Okay, that is great. Let me make the screen somewhat bigger. There. So now I should be able to... Oh god, I need to adjust this. Okay. Hold on. I need to capture it. Okay, yes. So now I need to... Okay, let's make it a bit smaller. Okay, so does this now work? Let's see. Let's take the macro lens off for now. Yeah. There's my camera. My screen. Me. Hello. Okay, let's enable a setting here. Display setting, high temp highlights. I like that setting. You can see what it does. It kind of changes how it shows the image. And there's the tester. Tester's somewhat warm. Okay, let me make it slightly bigger. This one can be smaller, I think. Okay. Let's close the pole because it's in the way. End pole. So what did you guys think the barrel jack was going to handle? 15 amps? Oh, then it's going to melt. Okay, I don't think it's going to handle 15 amps. 10 amps, 5 amps, 3 amps. What? I think it's going to melt at 5 amps. What are you talking about? Okay. Okay. Let's put on the safety glasses. Just, you know, for if something explodes. Let's put the power supply here, but I don't think that's going to suddenly explode. Not with 5 amps. We'll keep all the wiring here-ish. And we can, you know, use the thermal camera to... This is the barrel plug. Need to be somewhat further away. You can see my fingerprints. Okay, let's turn on the power supply and see if it explodes. It didn't explode. And now you can see real time on the screen that the tester is seeing voltage. That's good. Okay, it's set to 1 amp and it's currently off. Oh, the off is somewhat cut off. There. Yes, that's better. Okay. Well, I don't think it'll heat up. Oh, it's already heating up. What? No, that's because I touched it. I think. Is it? Yeah, maybe. And my mouse is also warm in spots. Okay. 1 amp. Let's go. On. Yeah, it's ramping up. Okay. That's not very exciting at all. Wow, we already went down to 11.47 amps. Volts. We're drawing 11.48 watts because of the voltage drop. And we're drawing 18 watts from the socket. Wow, that's bad. Okay, let's go to 3. Because I think it already won't handle 3 that well. Okay, it's going to 3 amps. Okay, so do we see anything getting warm? This little wire here. It's not warm, but it's like 28. It's not so much the barrel connector, it's the wire, it seems. The tester doesn't care. Power supply. Power supply doesn't care. Yeah, this wire is heating up. Oh, it seems my graphs, my numbers have gotten small again. Oh, I updated the software. That's probably why. Where did I fix that? Settings? No. Over here? Yes. 36? Ah, yes. Good. Now we have huge numbers. Okay, so the cable after the WAGO is currently the problem. It's not even the barrel jack. Yeah, we only have 10 volts. Below 10 volts. Yes, Foxnair. The overview you see at the bottom over there, that is from my new load testers. We did a stream about those last time. I don't know. It was a month ago, I think. Oh, indeed. It's not lit up. No, it is. It is. It is. It's very dim. It's very dim. And let me block out all the other light. You can somewhat see it. I need to turn off the lights. Hold on. This one, this one, this one. There. You can barely see it, but it's there. Ah, man. Why is it the cable? What kind of stupid is that? This barrel jack's fine. Look. See, it's like cold, but the cable is like heating up a lot. Chinese WAGO, yeah, sure, but then the other side would heat up too. So maybe it's not inserted properly. Let's turn the tester off real quick. Off. Yeah, it's hot. Maybe it wasn't crimped on the cable, or maybe it was on the plastic. Okay, so let's do like that. Maybe this one was also on the plastic. Okay, I redid the connections there. On. Ah, okay, that's better. Now we're getting 11 point something volts with 3 amps. I think I closed the lever on the plastic. Okay, hello. You don't lip read well, okay. No voice. Yeah, okay. Working. Okay, that did it? Okay. I don't know why. My bars were still working just fine. I just changed it to a different audio device and back. No idea. Okay, was it outputting so much EMI that it couldn't mic anymore? So, like, maybe there was so much interference that the mic just died. I don't know. Very odd. Okay, so, it reached melty levels. Yeah, that looks like a melted cable. Then again, the barrel jack is perfectly fine. So, I mean, I had it set to 8 amps. So these cables, they're really let down by the cable. That's stupid. Yeah, that's kind of stupid. Okay, well, next we need to test the power supply. So now, oh wait, do I need to, yeah, no, I don't need to remove this. Hold on. I don't know, the gauge is really small. Small cable. Yeah, it was definitely clamped on the conductors now. Wow, okay, let's throw that away. Boy! Okay, let's modify this one by snipping off the barrel jack. But this is, you know, I don't know. I don't know of any good barrel jacks. So, we're just gonna snip this off. There. Oh, there are lots of more copper inside there. Yes. Let's do it before the cylinder. It doesn't really matter, but... So let's try and get lots of cable. Okay. That's sturdy. There. The stream is buffering. I'm seeing 0 dropped frames. Same. What is going on? I'm seeing literally 0.0 dropped frames. This feels like better cable, so. Yeah, I mean, look at the amount of copper that's in here. Right? That's a lot better. Now, do we put wire ferrules on it or not? We do. I like wire ferrules. Let's see. Yellow, maybe? Can you measure the wire gauge of the power supply? That's a bit hard. I don't know how to measure that. Okay, yellow fits perfectly. Generally, that's about 18 gauge for yellow. The yellows are the 1mm ones. So, oh, this wire's thicker. What? Why is the white wire thicker than the... Is it? Yeah. The white wire is thicker than the black wire. What? Because this fits fine. This is a perfect fit. But this will never fit. So, okay, let's step up to black. Nope, even the black won't fit. Oh, wait. I am having dropped frames, but not because of the network, but because of rendering and encoding lag. What? Hold on, let me finish this. Interesting. Maybe I have too many applications open. Okay, so that crimped. What? Yeah, they're very different sizes. Right, so what is eating my CPU? Let's see. Task Manager. Let's see here. Details. Yeah, I can also hear it blowing. So something is eating. It says I'm 75% idle. Load application. That is the A-Torch application. Maybe it's too busy with communicating with China. Okay, I'm going to change some stuff then. No. It's can I share my? Let's see, window. Yeah, let's capture more. That is the absolute best solution here. Task Manager. There. So something is eating my CPU, and you can see some of the cores are overloaded. And when I was playing with it, I already noticed that the load application here, that is the A-Torch application, it's taking a lot of CPU. So I'm going to set affinity, and I'm going to give it the last cores. You're allowed to use this core and nothing else. Let's see if that helps. Okay, so now this process moved to this core. The first cores are still pretty loaded. So let's take the other application. Wait, why is there two? What? Oh, this is OBS. Okay, yeah. Is it better now? It's not a lot. I've dropped 115 frames due to rendering lag and 70 due to encoding lag. But you can see this core is being spammed. And these are now a lot quieter. So let's move my Easy DMM. What was it called? Yeah. Well, Easy DMM isn't using any power. Thermo Tools. Wait, sort by. Okay, Thermo Tools is also using some CPU, so let's also change that. And you're getting this core. Okay, let's see if that helps. Yeah, system idle is huge! Okay. Now this seems a lot quieter. I mean, you know, OBS is gonna, I'm capturing like 5 different windows and overlays and all kinds of crap. So OBS is gonna use some power. But at least now, none of the cores are overloaded, right? Okay, so this A-Torch application needs a core of itself. No. The thermal camera, I set it to never turn off. So I just need to charge the battery. Oh yeah, no, DDR4. It is 3600, and I've got 2 sticks of 32 gigs. I bought that way back when for a server, and you know, I just reused it for this workstation. And it's a 5900X, so 12 cores. That has to be plenty. I did upgrade the video card to a 5070 Ti, also bought for MSRP, because I wanted the video memory and especially the video encoding engines, because this has 2 encoding engines, and I'm recording in AV1, and I'm also streaming in AV1, so that I don't use as much disk space and blah blah blah, right? But this should solve it, and I don't care that this core is overloaded, because now only A-Torch is running on that core, right? So that should be fine. Okay, let's close that up and kill that window capture. Yeah. Good. Okay, we're back. We prepared this this cable here. Wow. Why is it okay? The positive is just like twice the size. Oh, damn it. That doesn't work. Yeah, these don't fit in a Wago. Okay, let me try and pull it off. Otherwise we have to snip it off. Yeah. Oh, that might work. I got the stupid plastic to come off. Yeah, that's even better. There. Okay, that's a good connection. Let's zoom this out. No, the holes aren't big enough, so that is the problem. Yeah, this is DDR4. Yeah. So I've had this for quite a while. This memory was in my workstation before I upgraded that, and I bought 96 gigabytes, so 2 sticks of 48 for $250, and then I was like, "Whoa, that's pretty expensive, but I'm gonna use it for 5 years, so let's do it." And now the same kit is 1,200 euros. So I'm like, what the? Anyway. Okay. Let's leave this somewhere like this. Do we still measure it at 12 volts? No, because no. Wait, why don't I measure anything? I never turned the power supply off. Uh-oh. That was bad. Then are we short-circuited? Okay, let's turn the power supply off. Let's do it now. Yeah, greedy people, Remy prices, I don't know. Let's go to DC voltage. Okay, I'm gonna do it differently. Yeah, I don't know what is what right now, so we're gonna put these back in here, and we're going to put red into black and black into white, because that makes perfect sense. Go. Okay, now we're at minus 12 volts. Okay. So black into black, red into white. Yeah, 12.27. Okay, so that was correct. Then why didn't the tester read anything? Is the connect... Oh, maybe the application is just crashed. Who knows? So, black into black, red into white. Yeah, okay, now it's reading 12 volt. I don't know what happened. Your 768 gigabyte server. Nice. Stock up on motherboards. Yeah, also SSDs have become insanely expensive. I'm glad I bought some 4 terabytes like half of this year somewhere. And those are now also 3 times the price I paid for it. So, yeah, anyway. I feel this is going to do quite well. So we're going to set it to 10 amps. And then we're just going to full send it. Is everything ready? Everything's ready. On. Okay. Some voltage drop is to be expected. Oh, we're getting some heating over here. Let me try with the macro lens, see if that's better. I mean, it's still not that much. On this side, yeah, we're getting some heating here too. That's okay. So this is 16 gauge. So this is probably also somewhat like that. You have a tablet with 128 gigs of RAM. Oh, you have one of those 13-inch AI stuff thingies. I mean, no, I mean, then all of them aren't happy, so I think this is okay. There's 10 amps going through there, so... Let's see if anything else is hot. Liquid cooled, yeah. Yeah, I mean, this is 16 gauge, so, you know, it gets warm. But, I mean, it's warm. It's not hot. It's like 26 degrees. What's it over here? Oh, wait. 30 degrees. It's warm. It's not hot. You have to remember that. Yeah, we're dissipating 114 watts and we're pooling 140 watts. Well, this chonker, it's not getting warm. That's my fingerprints. Maybe. What's this? Oh, I don't know. That might be the giant spool in there. And like the shape of the cabinet also doesn't match here. You can see me rubbing. So we can actually X-ray the power supply now. Yeah, the same thing over there. No, the positive wire is the larger one. And it's warm, but it's 34 degrees. That's okay. There's 10 amps going through there. So yeah, let's go to 15. Okay. We have 1 volt of voltage drop now. Power supply be like, don't care. Oh, sorry, that's true, Omakavala. I always get that mixed up. I know lower gauge is, but then if you say it out loud, I'm like, what? It's heating up a little bit. It's not too bad. Why is this shining so much? Oh, there's two wires touching? No. No, I don't know. And this is silicone wire, so it really doesn't care. This isn't. For 15 amps, that's okay. You want to see smoke? We just had a lot of smoke. My lungs are filled up. Okay, let's go to the max that it's officially rated for, 20 amps. You wonder if you keep audio. Okay, we're at 20 amps. And 10.5 volts. Yeah, that's the problem with this thing. Even if this chonker has no problem at all delivering 20 amps, which it seems like, the cable just can't do it. Right? Oh, it's 14 gauge. It says on here. Yeah, 14 gauge. Okay. Still, you'd want 12 gauge. Yeah, this power supply is like 30.5. Oh, the screen is measuring a different point. Okay. It's odd. The measurements I see on the device, let's see, is different than the ones you see in the software. See that? Strange. Yeah. Yeah, let's give it a little bit at 20 amps. How is the connection doing? 50 degrees. Okay, that's heating up. But I mean, what kind of connection then do you need to make? What? Sure, I think a screw terminal is better than a Wago, but I mean, how much from the wall? 275. So we're losing 75 watts somewhere. That's a lot. Of course, there's, inefficiencies in the conversion too. But the power supply isn't that hot. Easy peasy. So maybe if we screwed this into... if you screwed this like into a Dig Next 2, for instance, which has a much better power terminal than the Wago, it can make a much better connection there. Maybe it would do better. Because it's the connection point that's heating up right now. These cables also heat up. They're 40 degrees. I mean, that's okay. There is 20 amps going through them. And this 16 gauge cable is actually warmer. So I think it's true that this is 14 gauge. Because the 14 gauge is less warm than my 16 gauge. So, yeah. Oh, the Wago, I think they're rated for like 30? I don't actually know. This is, of course, a clone Wago, so... But, I mean, we're evaluating the power supply, and as it sits right now, it's doing this for like a few minutes already, just fine, no problem. It's still cooler than my hand is. Maybe this spot is like getting close, but... Yeah, PSU I think is doing just fine. So let's go 22. Right, we're testing the power supply mostly. Although the cable is part of the power supply in this case. Yeah. Okay, 22. I mean, this part is, yeah, 40-ish. That's okay. Yeah, I think you're pretty good, pretty on spot there, Criva. I'm just going to send it. 25, let's go. Oh, wait. Oh. 25. Will it shut down? No, it does not shut down. Now this is probably getting even warmer. Yeah, my 16 gauge is 68 degrees. 65 degrees. 65. Okay, so my 16 gauge is definitely. Oh, okay, yeah. My 16 gauge is definitely the limiting factor here. Because the cable from the power supply is like 40, 47. Here's some pieces close together. 48, 50. Yeah, you know. And of course the Wago is like warmer, but that's to be expected. Yeah. This might go on the recommended list. Actually, I think it will. Combined with a Dignex 2, perfect. It's like huge, but it's not even warm. Okay, let's go 30 amps. Do you think it'll do 30 amps? Okay. Okay. We're at 9 volts, but it's the LED controller that should have released a while back, but is releasing very soon. No, it's still coming. But I mentioned the Dignex 2, which is this guy, because it can take at least 12 gauge with wire ferrules into its input, and it can do about 20 amps. So if you're running a 12 volt setup, maybe this power supply is pretty good for that. Okay, so now with 30 amps, this cable is also heating up. And our silicone cable is at like, 90 degrees? 100 degrees? Well, this is certainly the limiting factor here, and the cause of the voltage drop. I'm gonna back off for now. This power supply still doesn't care. It's like, well, the cable is 50 degrees, but the power supply itself is like 44 degrees. Okay, let's turn it off. Well, let's talk about it a little bit, I guess. So the Dignex 2 is one of my next generation LED controllers. It has a, well, let's say 20 amp input. I put 15 amps on there for the rating. That's just to be a bit conservative. I've tested it up to 30 amps continuous without a problem. So it has 3 power outputs, one fused with 10 amp, 2 fused with 5 amp. So you can pool 20 amps continuous, and that's why I kind of wanted to look at this power supply. These two together make a great match, and I think the connection you get with this terminal will be a lot better than this fake Wago, basically. And then the cabling isn't the problem, and you get a nice little contained set with a nice enclosure. It has a built-in microphone, 2 data output channels, 3 times positive, 3 times negative, individually fused. It has DC relays inside, so it cuts off the power. It has a AC relay port to connect the relay over here. Some expansion, USB-C for standby, external Wi-Fi, all new circuitry for the power, the DC-DC handling. For the level shifters, there's a new circuit in there. Next generation Quinn LED, basically. It's in the spirit of a dig to go, so it has a nice custom enclosure, etc., etc. But it can handle 5 volt to 48 volt. So this is also going to be, we had the Power 5 HV, which can do 48 volt, but this guy can also do 48 volt. It can do true 5 volt, so even if you run it at 4 volt, it'll still work just fine. Lots of upgrades. I2C port over here, expansion port over here, built-in microphone, external Wi-Fi. I don't know what I need to say about it. It has all the things, and then all the things upgraded versus before. So yeah, that is going to release very soon. And it's not meant to replace a Dig Uno or Dig Quad, but sit beside it. If you don't want to build a box and do all kinds of DIY stuff, this is a nice fully enclosed controller, which still does come with a fuse per output channel and some really nice upgraded features. And then I could understand wanting it to pair it with like this type of power supply instead of a frame type power supply with exposed wires and contacts and things like that. So this would make a very nice combination. Later, Philip. Thanks for being here. The size is comical, of course. But this thing can handle the power output that this power supply can deliver, because this board is suited up to 15 to 20 amps. No Ethernet. No. I thought about it, but it would make everything bigger and more expensive. It's already a fairly big controller because the PCB is just packed. I couldn't get it any smaller, and adding Ethernet would make for a much bigger expense. There's no room to put a port on there, actually. Well, it's the next generation, Foxnair. We debated about the name a bit, but this is the best I could come up with. But there will be other variants in this lineup with the same DNA or the same idea behind it, basically. No, it needs ventilation. There's no Dig Next 1. No. The 2 is from the 2 data outputs. And so it sits between a Uno and a Quad. One of the limitations of an Uno is that it only has 1 power output, although it has 2 data outputs. The Quad, of course, has 5 or 7, depending how you look at it, the power. But then 4 data outputs. And this has 2 data outputs and 3 power outputs, which I think is ideal for most applications up to 20 meters. I have a whole wiring guide for 5, 12, and 24 volt. But even with 5 volt, you can reach 10 meters. But with 12 volt already, you can reach 20 meters because you can do a front, a middle, and an end injection. That's also why it's 5, 10, and 5 amps. Yeah. No, the Uno and the Quad will stay as they are, although there might be upgrades this year. Shh. But, this will sit alongside it as like a Dig to Go also does. And I think it'll be very nice. Right. We're already 1.5 hours in. It won't be possible via the USB-C. Maybe in the future you'll be able to do it with the Q expansion port. But maybe. Yeah, Foxnair, I've been thinking about that, but it's hard to figure that out. I did not fix the typo, Medved, because the cases were already printed. So that is what it is. Okay, let's turn this one off. It's still reading voltage. Oh, that's fluctuating. Wait, I turned the power off. It's still... We're still reading 12.31 volts. Oh, there it went. Okay, okay, now it's gone. Good. Sure, Discord's always fine now. So this one, for now, for what we've been able to see, gets a highly recommended. Right? If you want an enclosed style power supply, this would be perfect. Does very, very, very well. Cool. Okay. What do I want to look at next? I don't know. Maybe we'll try one of the one of these. No, I don't believe there are different versions. This one comes in 12 and 24. The other one only comes in 12 as far as I'm aware. Okay, so for the the DC side, this is pretty easy. We need to strip it more though. And let's put it like that. What's this for? This is testing power supplies to see how well they do. And if they should be recommended or not. Okay, for this, we'll also use a Wago. Oh, for this, because, you know, so we need to strip those more too. Oh, this power supply? Well, officially it's waterproof. I never understand that because the connections aren't. But, you know, these aren't that expensive. These are like 20, 25 bucks. And we're testing to see if they do well. And, yeah. Yeah, they just reuse the same cables. I've seen that before. Do I need to make a cable? I don't know. Hold on. Probably. Oh wait, maybe I have some in here.
They talk about another kind of world.
Come on. Yep, this will work. Let's unscrew this. What do you mean SMD version non-waterproof? Can you elaborate? find the correct waggle. Let me get one. Oh. Okay. Oh, a non-cob version. Well, I don't tend to create what already exists and does well, because I can never do it for the same price they do it. So there's already a lot of LED strips out there like that. And I'm not sure I could improve on those like I did with the cob version. So, no, I don't think so. Okay, let's put these in here. And match that up over here. I don't want to test waterproofness, no. Blue to blue. And then brown to brown. There. Okay. Let's get this on the screen a bit. Now this will go up to 20 amps officially, 20.8. We will see about that. Okay. This needs to go. Okay, ready to turn it on and go. Okay, we're seeing 12 volt. How do you turn power off if something goes wrong? Well, the switch is right here. I reach for the switch and I turn it off. Yeah, this cable isn't really bendy, so we're gonna have to leave it like that-ish. Okay, let's not start with 30 amps, but I don't want to take too long either, so let's start with 10 amps. Okay, 10 amps. Go. Let's get the heat camera. Okay, we're getting, let's see. Let's wait for it to ramp up. Okay, 11 or 115 watts, and we're pooling 138. Yeah, but Greg, there's technical reasons why that works on a cob and it doesn't work with SMD. Yeah. Of course, this is heating up a little bit again, but that's to be expected. It is home ace, yes. I mean, this looks hot, but yeah, it's not. It's warm. Who knew my 16 gauge would be the limitation? Okay, well this is not exciting at all. It's getting a little bit warm. Not that much though. So let's go to. We'll just send it 20 amps. Let's go. Beam. Uh-oh. Nope, it didn't like 20 amps. Aww. I was hoping this would be the one. Okay, let's see. 15 amps. And on. Nope. It's refusing to do 15 amps. Oh, now we did it. Okay. Okay. Cool, homies. Yeah, I know a thing or two about hardware design and releasing them and selling them. No, that's the power tester. That's beeping. Any tips? Boy, I don't know. Take your time. No, I'm not saying don't even start. I'm doing pretty good with it. So, I mean, it's possible, but it's going to take time, right? And I don't want to be a one-hit wonder person, so I don't do any Kickstarters or things like that. And I built the business up slowly, but sustainably. I think that's the way to go, in my opinion. But yeah, there's a lot of, things you can do. Yes. Noob here, do you have any idea of what is the expected temperature a power supply with 300 watts and 30 amps can get? I'm running a 15 meter LED strip and a little concerned about the temperature. About the temperature of the LED strip or the power supply? So the power supply can easily run, I don't know, 50, 55 degrees centigrade. Depends, does it have a fan or not, etc, etc. And also for the 15 meter strip, you need to be at least injecting front, middle and end, depending on the voltage, maybe even more, to reach anywhere near those numbers. So, yeah, this power supply seems to stay pretty cool. Well, it's warming up a little bit, but this connection is much warmer, so let's get that off the camera screen. Yeah, it's heating up. Thanks, Foxionaire. That is definitely my motto. I try to do it well, and otherwise, and some stuff is already out there that does it well, and then I don't have to do it again. But I try to differentiate with high quality stuff. Okay, 15 amps it seems to be doing fine. So let's go to 16 amps. Okay. 17 amps. Okay, let's go to 18 and hold there for a while. 18 amps. Oh wow, the voltage drop. Oh no. It can't do 18 amps. Aww. Okay, let's go back to 15. No, it doesn't want to turn on. Oh, look at the voltage. We're still at 11.558 while there's no load. It's slowly creeping up. We're now at 11.64, 6.5, 6.6. So maybe there's some kind of protection mechanism which is cooling off. Yeah, we're at now 11.7. The rated power supply for this one is 12 volt, 20.8 amps, which it is not doing. So let's see. We're going to start again with 15 amps. Okay, starting up. Ah, that's good to hear, Leandro Armento 7804. Okay, yeah, then you could draw like 16 amps potentially, so you could reach like a decent draw on the power supply. But why are you concerned about the temperature? Does it feel hot, or I mean? So the voltage drop as we're measuring right now, you can't really determine because we're getting a lot of voltage drop from this 16 gauge cable here. So, yeah, unless it starts dropping a lot, don't read into that too much. This thing is probably still making 12 volts. We just can't see it right now. Actually, we could by using this guy. Hold on. Let me turn this off. Turn this off. Let's do a 4-wire measurement, as they call it. Not using the tester, because I like seeing what voltage drop we're getting. But using our multimeter. I hope these fit. Yeah, they should. Okay. Okay. Oh, what? Okay. This clamp isn't that great. Okay, good. And now we get our multimeter probes. And we add them to the mix. There. Let's see if we can measure the voltage. Yes. Okay. Oh wow, it's still only outputting 11 point something. So the value you see at the top of the screen, where's my mouse? Over here? You can't see my mouse. That's fine. Over here. That is being measured at this block. So it's basically the voltage that is seeing it over here and not all the way through the long cable to my tester. So now we have 2 voltage measurement points. Currently, they are basically the same because there's no load. But now let's hit the 15 amps. Okay, we're doing, well, almost 15 amps. Wait for it. Okay, close enough. We're doing about 15 amps. And at the tester, we're seeing 10.6-ish volts. But over here, we're still seeing 11.4 volts. So that is the actual voltage you could expect when you hook up your controller, because it would be right over here, right? So even with the load on there, the controller would still see that because it doesn't have all that extra cable. It would, however, have this part of the cable. So this measurement you see in the yellow on the top right is correct. That is the power or the voltage your actual device will see. Oh yeah, if you've got the money, Greg, Meanwell's the way to go, for sure. Yes. So even just this 16 gauge, which isn't thin, to my tester, it drops like a volt. While it's only a meter, or it's how long is it? A meter? Yeah, something like that. It seems the power supply is still dropping though, if you look at the numbers. So that means it can't really sustain this load, I think. Is the output wire labeled? That's a good question. I can check on the other one. Oh, it is. 3 times 1 millimeter square. So that's like 18 gauge, I think. I guess it's on here too. Yeah, 3 times 1 millimeter square. Yeah. Now this is going to be nice and warm. Sure, I mean, yeah, sometimes you find a good one like the previous one, but meanwhile, you can't go wrong, but you might also be paying double. You know, that's just the thing. So we're now at 11 volts, or below 11 volts. So even 15 amps, it seems this guy can't really sustain. I have some Foxionaire, but I do test them first. For sure, Umakavala, for sure. I don't know what's up with this dropping voltage there. It's just weird. Aw, I was hoping this would be a good one. A countdown timer, exactly, little Papa John. For some reason, it's just counting down. Yeah, they're made in China. My stuff is made in China too. It very much depends on who designs it. Like, my controller says 15 amps, but you can easily do 30 if you want to. Well, I wouldn't recommend it, but it won't die or break down or do weird stuff. Where if you buy like other controllers out there, which say 15 or 20 amp, once you start doing 10 amp, they don't do so well. I don't know. Maybe let's put it on its side. Or like that. Hold on. No, it's still going down. It just keeps going down. What's going on? Does it count faster if you increase the load? I'm afraid if I increase the load, it'll shut down again. But I mean, I can already tell you this is not suitable, right? If a 20 amp PSU can't do 15 amps continuous, sure, Greg. Thanks. I don't know. You know how good is it? What good is it if a 20 amp PSU can't do 15 amps? Then it doesn't even support the 80% rule, right? So I mean, let's go to 12 amps. See if that changes anything. Okay, we're now at 12 amps. Oh, now it's counting up. Yeah. That for sure indeed is a temperature issue. Aw, I really wanted this one to be good. I guess it's a fine 10 amp supply. Oh, it stopped counting. Oh no, is it gonna go down again? No, it already shuts down by like 16, 17, 18. Oh, it's going down again. No! What do you mean? I even propped it up so it's not touching the ground or the table anymore. Oh, it's now 60 degrees-ish. Nope, now it's going down. Jesus, that's useless. Okay. I think I can still leave a review for this one. So let's do that. Okay, so maybe 10 amps is okay. Okay, let's go to 10 amps. But that's not where you buy this stuff, right? Big Bad Joe, we actually tested two 5-volt supplies a little while back. Okay, let's turn it off. I don't like this power supply anymore. Now you can see the voltage rising. This gets the shake nod of disapproval. There's some kind of protection mechanism in there, which is probably temperature controlled. Ow, it's hot. Okay. Let's see if I blow on it, if it counts up faster. Did that change anything? And maybe it did. Yeah, no, I think I'm done with this one. Ow! Well, it could be a PTC home ace, because those will raise resistance when they heat up. But generally they're quicker than this, so it might be a different type of circuit. Okay, I think I'm done with this power supply. I'm turning it off. There. Maybe if I turn it off, it's still voltaging. Turn off. Okay, there we go. That's right. You can use water cooling, little Papa John. That is a very smart suggestion. Might actually be a fun live stream. Water cooling your PSU to get more amps out of it. I don't know. It would get views. Okay, let's turn it on again and see what we get. Yeah, no, it's still counting up. And maybe Dutch Taurus, but then I don't know if you'd see this kind of issues. Okay, I have time. I want to do one more. We're already at 2 hours. We'll leave the 48 volt GAN for another time. We have this one, but then the 24 volt variant. I'm actually curious. I want to test this one. Okay, power is off. Good. Oh, that's very kind there, Greg. Tell him I said hi. Oh, these are actually stripped more. Good. Okay, that's good. There is a link on quinled.info if you really want to. It's absolutely optional. But there is a link to my PayPal in the About section, I believe. Or the More section. It's in the right menu. I kind of hit it. Because I'd rather people just buy a controller than donate. I mean, it's fine to donate, but, you know. Oh, yeah, Dradstal found it. Okay, so this is the same power supply, but then 24 volt. I just did read on it. If we look at the values, it says the maximum power is 250 watts at 50C. Well, it exceeded 50C. And they say, warning, high temperature, please don't touch the surface and install in ventilated place. Well, is my office a ventilated place? I don't know. So maybe you're supposed to put a fan on it? No, that's stupid. I don't want to put a fan on it. Okay. So this is the same power supply, but then 24 volt. Still, let's see how it does. Power. And we're getting 24 volts. Yep. Thanks, Foxionaire. Gary, if you're adding a microphone and you're using Q1, then you have to either choose if you want to use that for the relay or the microphone. Or you can spread the wires differently over Q1 to Q4 and configure them as you have them connected, right? Okay, well, it's doing 24 volt now. Have my wires cooled down? Yeah. What's this? Oh, that's the Wago? Yeah, that's the old Wago. The old Wago is still warm. Okay. Right. Let's go. No, not 10 amps. The max is 10 amps for this guy. So let's go to 6. Because it's 24 volt, right? So it's half the amps. Ah, 6 is boring. Let's go to 8. 8. Go. Come on, don't disappoint me now. Ah, thanks, Dradstal. That's appreciated. What? How are we at 17 volts? 18 volts? That's not right. Okay, it can't do 8. 7? It's better. Let's wait for it to reach like a decent voltage. I know, Fonctionnaire, but I don't know. Maybe at 100k. The problem is it also takes... If I do it, I want to do it right. And there's only one guy who does this, me. So anything I do other than YouTube or developing hardware costs time. And then I have to do something else less. And I'd rather spend more time developing hardware than making merch. Does that make sense? So, you know... yeah. Yeah, we're still only at 22.5 volt, and that's not because of voltage drop. Because this isn't warm at all. Let's back it off to 5 amps. Yeah, now we're getting around 24 volt. This is what I expect to see, right? A little bit higher, preferably, even. Maybe a fan wants... Yeah, but... I get that, and that's appreciated, but then it isn't done by me. And I already have my Quinological guys, and they help me out a lot, actually. Especially on the Discord, but also some things behind that. Like Philip does a lot with the flasher, and Paolo helps me, CJ helps me with firmware and other questions and issues. And so there's already guys helping out, especially, you know. But, yeah, there's only so much time. Yeah, no, you don't want to wear that one, Greg. It's horrible. Hey, Just Rod Murray. Okay, so this is a horrible power supply. 4 amps? I guess maybe that's voltage drop, but why is there so much voltage drop at 4 amps? That doesn't make sense. Those bent fins are the cause. Yeah. No, I think I'm gonna leave a few bad reviews after this video. Later, homies. 6 amps. Come on, it has to do 6 amps. It's not doing 6 amps. Well, nope, there's the countdown clock again. What do you mean? Thanks, Omes. I don't understand. Why is it so shit? I really tried to buy power supplies, which I thought would be good this time. More power supplies for the waste pile. No, it's not already overheated. It can't overheat. It's doing nothing. Oh... Yeah, that sucks. Okay, let's go 7 amps. Thanks, Gareth. I like doing them, so... Yeah, no, look at the voltage. This is the definition of what you call a LED power supply. If you ask more current, let's go to 8... it just drops the voltage. It doesn't actually give you more current. Look at the watts. The watts are going down. Right? So I ask more current. It gives me that current. But it lowers the voltage so much that we're actually getting less watts instead of more. But if you have an LED strip connected, you'll notice this a bit less. Except that it just doesn't change anymore. This is just how bright it is. No, it's your power supply. Yeah, no, this is bad. This is... The other one, you know... Oh, 9... Oh, no, no, can't do 9. Doesn't like 9. Nope. The 12 volt one at the 10 amps, maybe. This one is just one big nope. Okay, I'm done with it. Horrible. Horrible power supply. Okay, bad. Let's wait for the voltage to go. Oh, I hate it. It sucks. Do not buy this. Okay. These are not the meant well, yeah. Okay. Let me read a question. Quindo, if you don't mind asking, what made you get into YouTube and doing amazing products with Octa and Quad and Queen LED? What made you start making your own and doing an amazing YouTube? So, 10 years ago, we were designing this house. We're currently designing a new house, but that's besides the point. And I wanted to have every light, mostly LED strips, remotely controllable using home automation. And that was, you know, a bigger task then than it is now. And I calculated what it would cost with Philips Hue and stuff like that. And I was like, what the hell? I'm not going to pay that. That's insane. And so I started to develop an analog controller, the Queen LED OG. Half of the house is still running on Queen LED OGs. I published those designs, I did a few updates, and I did some blog articles about that. And then at some point, I wanted to explain more about it and stuff like that. I started the YouTube channel to explain more and show more and do some reviews and things I'm passionate about and I like sharing. And, well, that kind of escalated. Yeah, that's kind of how it went. Okay, do I want to test one more? Because that one just sucks. It's bad. Bad, bad, bad. Okay, let's go for the 24 volt. Then I have to hook up the second tester. I don't want to hook up the second tester right now, so we'll do this one another time. What do you have here? Okay, we'll try this one for fun. This is something which might be useful for diff power in the future. This diff power is something I'm working on where it's a system basically based on Ethernet cabling where you can run power and data over Ethernet cabling, not as network, but still using the same Cat5e cables. And yeah, get data and power to your LEDs that way. Maybe we have something to show you after this. And we're going to do that with 55 volt. Now, this guy is 54 volt and 3 amps max. So that sounds like a good fit for the Sender 1. Let's prepare this one. I don't care about the barrel jack. Barrel jacks be damned. There. Okay, let's strip it. Now this only needs to do 3 amps, so you know these conductors are really tiny, but that's okay. Okay. I'm just going to put some ferrules on there because that's how I roll. Maybe the white ones. Well, you can still use diff advanced, but then use it for 1. I know that's more expensive, but that's partly because there's just more hardware on there, right? There might be a revision of Diff Solo at some point, but I don't know when. So, Diff Solo was really meant to keep it cheap, and okay, yeah. So that also means it has more limitations. Diff Advanced is built with less limitations, right? Okay, let's see here. They all want Quinn LED strips, cool. Where's my power? Oh, right, I need the normal plug. Okay. So this can go here. Do I have one here? No. No. We'll use this Chinese one. Okay. Let's see here. This should be good. Let's turn it on. What do we see? 54 volts. Perfect. Good. Okay. So that's at least good. It's giving us a nice and steady 54 volts. Let's have it do 2 amps. It's rated for 3. So let's see what it does. Go. It doesn't do it. Damn it. Let's try it once more. Oh, yeah, there it goes. Okay. Okay, we're getting 107 watts and we're drawing 120 watts. That looks pretty good. And we're only doing 2 amps now because the voltage is so much higher. So we don't really have to worry about voltage drop or anything like that. So we're getting 53.82 on the power on the load, and 53.87 on this measurement point. So we don't really have much voltage drop to speak of on the cable, right? Okay, let's have it do 2 amps for a little while. My table is the warmest because that's where my hand was. 54 volt is commonly used with PUE. PUE used to be 48 volt, but with newer specs they kind of upped it to, I believe now, maximum 57. So you see a lot of 52, 54, 55 volt PUE injectors. That's just a gag thing we have, Foxionaire. I own 100% of my own company. No worries. But I do listen to Philip. Philip has been here a long time, and if he says something, I listen to it. Yeah, the power supply is the coldest thing on the table. It's the black thing here. So, even my fingerprints, let's see. Yeah, now they're the warmest. Okay. Well, the 3 amp power supply does 2 amp, no problem. Let's go to 2.5. Come on, power supply. The voltage is remaining pretty stable. We're now doing 134 watts on the measurement device and 148 from the wall. Yeah, sorry, Gareth. Gareth, I didn't see your comment before. Yeah, that other power supply, I hate it. It's stupid. I'm gonna literally after this live stream go to AliExpress, make a cop or a screenshot of the live stream, and leave a review that it sucks. Because I'm petty like that. If you sell me a 20 amp power supply and can't even do 10 amp, you're gonna get a bad review. Okay, well, this seems pretty stable. It's still... Oh, look at that. Something happened. Something got 26 degrees. That is to help other buyers. That the whole thing about these live streams, I think it's fun to test these things, hang out with you guys, answer questions, but also it's consumer advice. Like, these things suck, right? Don't spend your money on these power supplies. And if we find hidden gems, like the 5-volt ones we found, those are great. And that brick we just tested, that is awesome. That's perfect for a dig next to, for instance. So, yeah, I mean, that 30 degrees... No, the LED is over here. So that's not the LED. But I mean, my hand is still warmer, so... yeah, backside doesn't care. It's amazing, right? How much this thermal camera is very sensitive. Like... No, I don't... this one so far is doing great. Voltage is stable. No problems. And we're at 2.5 amps of 3 amps max. That's okay. That's fine. And I'll show you later why I'm testing this power supply specifically. Yeah, all good so far. Will it do 5? Let's go to 275. Oh, there he goes. Yeah, we're at 147 watts drawn and 162 from the wall. Voltage is still stable. No weird countdown clocks or something like that. I mean, it's not even 3 amps. This doesn't care at all. The cable is not warm. Oh, my tester is no, okay, it's not really warm. Yeah, exactly, Foxionaire. I mean, this is not a metal frame power supply. Inside it probably still has a metal frame. But if you're seeing like 36 over here, that probably means it's like 50, 55, 60 inside of it, right? You have to keep that in mind. Okay, I'm convinced it does 2.75. Let's go to 3. It's amazing. You enter a higher amperage and the wattage actually goes up. It's almost like that's how a power supply is supposed to work. Okay, we're doing 3 amps. Voltage is still pretty much the same. 53.8. That's perfect. We're doing 161 watts and 176 from the wall. Sure, what happens after 1 hour? Sure. I bought this specifically for about 2 amp load. So if it does 3 amps, you know, buy one, cry once, mean well. Yeah, true. You think it'll do 5 amps? I don't think it'll do 5 amps. No. Well, let's give it a bit of time. So far this is fine. Yeah. Yeah, I mean, tester doesn't care either. Although the tester is doing 161 watts, so the exhaust is warming up the cables behind it. It's not too bad though, I think. Let me check. Those go to my LEDs, so that's okay. Yeah, so the trick with the thermal camera, once it connects, never disconnect again. Luckily it has a large battery. Yeah, at least, yeah. Because plastic is a bad thermal conductor. So if the outside of the plastic is getting that warm, something inside has to be much warmer. Voltage might be slightly dropping. Let's keep an eye on it. 805. Yeah, this is a new tester, Gareth. In the previous live stream, we tested a lot with it. No, it's fully enclosed, fully closed power supply here. Oh, we went to 804. We're back at 805. Let's go to 3.5. Oh, here it goes. Oh, it's dropping a bit of voltage. Then again, that could be voltage drop on the cable, so... Okay, we're at 3.5 amps. We're drawing 187 watts in the tester, where you can see that yourself. And we're doing 206 watts from the wall. Yeah, a little bit of voltage drop with half an amp. That's to be expected, so that's fine. Yeah, this is a 8-torch BW600. I have it listed in the video description. Three and a half amps. I don't know. Let's go to 4. 400, 4,000. No. 4. It seems to be doing it. No, it's not doing it. See how the wattage is now, once the amps climbed, but the wattage went down? That is because it can't do it. See, the voltage is now fluctuating and sagging and doing all kinds of weird stuff. So let's go to 3.5. Yeah, now the voltage is climbing again. And it has a small display on there. Yeah, that's not bad at all. That's actually pretty good. Yeah, we're still at 3.5 amps instead of 3. That's great. That's perfect. Let's go to 3. Nothing to complain about. It's not getting overly warm. It's warming up, but not like at an insane rate. Yeah? Awesome. So let's use it. Does it have short circuit protection? I don't know about that. We're first going to use it. Let's turn it off. Okay. Because one thing, people have been asking about diff power. And I have been working on it. Although slower than I'd like, but still. And I have a new board that I've been testing. There's a lot of technical differences in it, etc., that is a bit too hard to explain maybe, but I have it on my desk here, so it's like, let's do that as the last part of the show. So we have this guy over here. I have a power connected, but let's disconnect this power. If I can find the right screw thingy. There. And I'll explain what this looks like in a minute. Okay. Okay, so, okay. Beneath my desk, I'll get it real quick, just to show you, is this giant roll of 100 meter U2P cable. Okay? I'm gonna put it back now. And, I'll explain this real quick. This needs to be on this side, this needs to be, okay, this can go over here, yeah. Okay. So, this board here is the current newest prototype of the diff power sender 1. So this takes in one data signal and then sends it with power over the U2P cable to the other end, where it then goes into this board that converts it to whatever you connect, in this case 5 volt, and then you can connect an LED strip and run it over that 100 meter U2P cable with power and data. Okay, so what this board does more, you input 55 volt, so let's do that. In this case it's 54 volt, you can also use 48 volt, that doesn't matter too much. But it converts it down to 5 volt for its own usage, and you also get a 5 volt output in the form of this terminal or this USB connector, which I have connected to a brain board, so it gets 5 volt from the sender 1, so you can power like an ESP or a brain board or something like that, and then from the brain board I have one LED data connection going out of it, because there's no ESP on here, into this board, which it will then send over the UTP cable, right? So then after that UTP cable, we have our receiver board, and yeah, you have, of course, we have like 50 something volt coming in, although it might be 48 volt or 42 volt after the UTP cable. We then use a buck converter, which screws on to the top basically like that, right? So this is a standalone unit, but it's dumb. There's no logic in here. The logic is on this side, and it outputs the data signal to the LED strip. Now I need to see if I actually have an LED strip here I can use. Maybe this one? I don't actually know if this one works. I might have blown that up. We'll see. I know it's 5 volts, so that should be fine. The buck converter right now isn't screwed on because I was measuring stuff on the board. So in theory, this has 100 meters of cable connected. I don't remember. There are some issues with this prototype still. Don't ask. And let's just hit the power. Okay, good. Seems the brain board also turned on, right? We have LEDs. Oh, I don't have Ethernet in there. I need Ethernet. Ethernet also works. Noise. The reason for an external one is designing a buck converter that does like 5 amps, 10 amps, etc. from a very high voltage is pretty special design, and I wanted to fix or make this first as a V1, and then in V2 we will have boards with integrated buck converters and things like that. So for now I didn't. Sometimes you have to choose your battles basically. So I don't think this LED strip works. Let me turn it off real quick. So the idea absolutely is to have that in the future, but that would delay the system even more basically, right? Do I have something here? No, I need to get some LED strip from the garage. Hold on. Okay. Okay, so we have some LED strip over here. Still the same setup, 54 volts going in. It gets made into 5 volts for the brain board over a USB-C because that's just easy. And then it gets also sent over this UTP cable. It has full protection and remote negotiation and blah blah blah. Then it goes to this module, gets buck converted down back to 5 volt. So it doesn't really matter if we get 52, 44, 42 volts on this side. As long as we can still make it 5 volt, that's fine. Power. Did I blow something up? No. Oh, right. Yeah, this board still has some issues. So some logic is not working as intended. So probably, yeah, I need to remove this jumper. Don't ask, okay? And now our LED strip is working through that 100 meter cable. It's blown out. There. And you can see it's working. Yeah, there's some logic that's reversed right now, okay? And I can show you that it's actually working, because I can disconnect this. Okay. And reconnect it. Still works. Yeah, it's going through here. It's a massive amount of cable, but you know, 100 meters is a good one to measure with, to test with. Let's see what voltage we're getting on the other side. Let's see, this one and this one. Yeah, so we're sending in, let's see, we're sending in 54.0 something, and we're getting back 52.8. Now, normally you have to worry about voltage drop and all kinds of other crap, which we're still getting, but since we have a buck converter on the other end, we don't really care. As long as we can make 5 volt from that, which we can, that's fine. And that's how you transport data and power with a single cable for very long lengths. Yeah. So yeah, these are the newest prototypes. Some stuff is improved, some stuff needs work. These LEDs are way too bright. The logic is working in reverse in some ways, but other stuff is working fine. So yeah. Let's disconnect it again. Part of the logic that's not working is the delay circuit, so this is kind of playing with fire, but the protection circuits seem to be working well. Yeah, anyway. No. It does a form of detection if the remote board is there, but it's very basic. So we'll test again later with the current circuit what happens if you plug it into a switch, for instance. You can use a patch panel, but you can't use a switch or a router or a hub or something like that. But likely it might blow up the port. So, yeah. Yeah, the delay isn't working. Normally, I want there to be a 1 to 2 second delay before it turns on the power when plugging it in, just to prevent any issues with hot plugging, right? As you can see, I have other protections in place which seem to be working okay, because nothing has died yet. But with the delay there, it's just going to be safer. Oh, voltages. Let's see. Basically, depending on your needs, you can get a... Yeah, you need to get a 50... I use 60 volt input buck converters. And then you choose a 5, 12, or 24 volt variant. That's correct. You might be able to do 36, but you're always going to be down converting. So 48, I don't think so. But if you're running 48 volt LEDs anyway, you probably don't need the solutions, right? So yeah, but you can just these bucks you can get in various sizes and voltages. Let me check. Finally, take these glasses off. I don't think it's going to explode. Is it this one? No. Probably this one. Oh my god. Oh, that's a heavy thing. So here we have a box that I use for testing. This is a bigger size I work with. It says 36 to 48, but it is 60 volts. This one can do 5 volt, 20 amps, because the system is designed around 100 watts. Okay. This one's also 5 volt output, but for instance, this one is 24 volt output, 5 amps, so 120 watts. Here is a 12 volt, 7 amp output. So you can choose whatever voltage you need on the remote side, and then use that buck converter on there. And in a future version where the buck converter is integrated, it'll have a jumper or a switch or something like that. Yeah, Foxinaire, that is the idea. Having lots of Ethernet cables which will do all the lighting and the networking and everything. This is single channel, that is correct. But I don't have a prototype right here. I can show you. That's the last thing I'm going to show. Is it in here? Oh, you can see all kinds of testing boards I've already made and done. This is, for instance, an analog receiver. So next to having a digital receiver, you can also have an analog receiver which does analog LEDs. Oh yeah, right. So here is a prototype I made. It needs a lot of work, but parts of it worked, parts of it didn't, which has 7 outputs. So you have a brain board. It does I2C to the board below it to turn on and off the outputs, because you can switch on and off the outputs so that the remote board is fully unpowered, and the strip also, to save power, and then there's also no power flowing. And well, this now has 4 inputs, but you can do up to 7. Yeah. This system is going to be for analog and for digital. So currently I have a digital receiver board connected, but we can change that receiver board, plug in the UTP cable, reconfigure the brain board, and then it does analog. Nice stash. Well, no, expensive stash of prototypes. Thousands of dollars of prototypes. So yeah, that was the last thing we were going to look at today. We've been going over 2.5 hours already, so... Did you try connecting the mounting hole on each board and then do the hot plug? What do you mean? But yeah, one of the features is that, for instance, right now, you have one 54-volt power supply, but you're still powering this brain board with 5 volt, all from the same board. What is the price of the rest of the material? What rest of the material? This is all you need. LED King, thanks. Great stream, excellent energy. Nice, thank you, Omukavala, thanks for being here, right? You're part of the stream. How is it that I connect a Dig Uno in reverse, my bad, and the Meanwhile, and it's still working. Device and the wires got warm for about 5 seconds, but still works. There is reverse polarity protection on there, which kind of sucks up the power, but if it didn't blow the fuse, And the onboard electronics has separate fuses, so... What is not the prototype? I am confused what you're asking, I test things. You mean the buck converter? This buck converter is like $10 or something like that. And the UTP cable is just simple Cat5e. I put the connectors on myself. And this is just standard WS2812B LED strip. Yeah. It seems like after I moved those programs to a core each, It hasn't hitched anymore, right? The stream. I don't see any dropped frames anymore. Thanks, Mark. Yeah, this has been in development for over a year already. Off and on, because there's other stuff going on. But we're getting there. We're getting there. There's a lot of things this does good. Other things that need improvement. Any more work to handling RGB CCT? How do you mean? The analog board I made for this prototype already does RGB CCT. There's no limitation on the ESP32 of 600 per channel. Let me link you an article. It is because of the LEDs we use. If you read this article, everything should be clear why that is the case. Rick Jagger. It's not been officially released yet. Do I have one here? But it has been unofficially released. Let me dig. You're getting another secret. I need to dig on my table a bit. I thought there was one here. Yeah, I think so. Yeah. No. Maybe. Yes, I think so. Yes, okay. You're getting another secret. Hold on. You guys know the dig to analog? Well, there is now a dig to analog plus RGB CCT version 1.R2, but doesn't matter. This has some upgraded features versus the dig to analog. Dig to analog isn't going away yet, but we'll see how it goes in the future. This has 5 channels, so it does RGB CCT. It has a much larger fuse that is replaceable, and it has 2 high power channels, which can do 5 amps for the cold white and the warm white channel. So, if that's what you've been wondering about, those should now be available in all the shops, and an official release will follow later. Gareth, yeah, software is a thing. Maybe different software like ESP Home or Moonlight or etc. Would work better in those situations. SLC, yes, but that is taken care of in the circuit. There's also bleeder resistors and other things. But it's not configured correctly yet. I need to work on that. Yeah, Dr. Z should have them listed on his website too. And he has them in stock, so I know he has them. So yeah, dig to Analog Plus. More power handling, more channels, higher PWM, etc., etc. Available now. Not yet announced. Cool. Anyway, I was rounding off. So far, this little power supply seems to be doing well. Let's see what temperature it has by now. Okay, my board's warmer. Yeah. Well, we're only drawing 10 watts from the wall, so, I mean, how warm is my board? Oh no. Where's my macro lens? Moonlight is different software like ESP Home and stuff like that for an ESP32 to run LEDs. You can check it out. Yeah, okay. My buck converter is a bit warm. That is to be expected. Other than that, it's... oh, there's an LED here that's warm. Or it's a resistor. That's also to be expected. Yeah, all good. My my brain board here. Cool. Anyway. For this time for real, I thank you all for watching, and well, stay tuned for another video or a live stream. I'm hoping to release a certain video really soon that something will be available. Okay. Thanks for watching, guys. Bye-bye.